Hey y'all, it's RobotDiva from STEAMDivas. You know, we're all about making robotics easy and fun, no matter who you are or what you look like. Today we're going to break down the code for the Bathroom Buddy, a cool line-following robot we built using our little friend, Lilybot. As a bathroom buddy, she's super helpful for little ones learning to use the potty. It's one of our smartest builds yet, using sensors, sound, and a state machine to move just like a little helper on a mission. Don't let this code intimidate you. We're going to take it piece by piece, so you'll get it, no problem. First things first, let's look at the comments at the top. This isn't code for the robot to read, it's just a little note for us. Think of it as a detailed sticky note attached to the program. This part explains Lilybot's whole job. It says she follows a line, listens for a voice, and avoids obstacles. It also lists all her connections, her motors, sensors, and voice module, so we know which pins on her brain, the Arduino, are for what. Next, we're telling Lilybot what skills she'll need. The hashtag include command is how we add special abilities. The first line, $include, gives Lilybot a way to talk to her voice recognition module. The second line, $include, quote, voice recognition, vi 3.h, gives her the specific language she needs to understand our voice commands. Now we have a whole section of constants. When you see const int, it means this is a number that won't change. This is good practice because it lets us name a value, like base speed, so we can easily change Lilybot's speed later without searching for it every time it appears in the code. We also give names to Lilybot's pins, so S_left is easier to remember than A1. Below that, we set up Lilybot's moods, or states. An enum stands for enumeration. It creates a list of names for us to use. Instead of using 0 to mean waiting, we can use the word IDLE. Tells us that Lilybot starts in the IDLE state. It does this by creating a variable named mode of the type mode and sets its initial value to IDLE. Setting up the initial value of your variable is called initializing, and this tells the code what is the value of the variable when the code starts. This next section, the setup function, only runs once when Lilybot is turned on or when the program first starts. Pin mode tells the Arduino whether a pin is an input for sensors or an output for motors. The serial.begin line opens a communication channel to our computer, which is super helpful for checking if everything is working. The myVR.load lines load the voice commands into her memory so she can recognize them. This part, the loop function, is the heart of the code. It runs over and over again, as fast as the robot can go. It's a constant cycle of sense, think, and act. The logic runs as a state machine, meaning the robot always knows what phase of its journey it's in. Sensing. The code reads from her sensors. Pull voice. Checks for voice commands. Analog read. Checks her line sensors and read distance, cm. Checks for obstacles. This is all of our sensor subsystems. Thinking. The switch, mode part, is where Lilybot makes decisions. It looks at her current state mode and the sensor data to decide what to do next. For example, if her state is out follow and she sees a black pad, she'll switch her state to wait at bath. Acting. The functions, like set motors and music on, make her do things based on her decisions. This is how Lilybot interacts with the world around her. This is what we like to call a deliberative process in robotics. The robot senses its world, thinks about its decision based on what it senses, and then acts on it. Here's the logic for line following. The robot reads the left, middle, and right sensors. If the middle one sees black, it goes straight. If the left sees black, it corrects left. If the right sees black, it corrects right. When it loses the line, it uses the scan behavior function to pivot left and right until it finds it again. This is a great way to keep the motion smooth and natural. The Bathroom Buddy doesn't just follow lines blindly, it can think on its feet. The ultrasonic sensor measures distance ahead. If something comes too close, maybe a toy or a curious pet, the robot pauses, calculates a curved detour, and then finds its way back to the line. This is the intelligent avoidance system. Let's discuss how the intelligent avoidance system works. When the sonar detects something close, say within 18 centimeters, the robot switches to avoid in it, then curves around the obstacle in avoid arc, and finally realigns itself with the line in avoid recover. It even adjusts the curvature based on how close the obstacle is. It takes tighter turns the closer it gets to the obstacle. The rest of the code is made up of smaller functions that do specific jobs. These are helper functions. This keeps the main loop nice and tidy. Follow behavior is the part that tells Lilybot how to follow the line. If her middle sensor is on the line, she drives straight. If her left sensor sees the line, she turns left to get back on track. Scan behavior tells her what to do when she loses the line. She pivots left and right until she finds it again. Read distance cm is how Lilybot uses her ultrasonic sensor to see how far away an object is. It sends out a sound pulse and measures how long it takes for the echo to bounce back. Hysteresis update is a fancy name for a simple idea. It's like adding a cushion to the sensor's judgment. It makes sure the sensor doesn't flicker on and off constantly when it's right on the edge of the black line, so Lilybot moves smoothly. In robotics, we call that type of flicker on and off bang-bang control. I hope this helps you feel more comfortable with the code. As you can see, even complex tasks like line following and obstacle avoidance are just a series of simple instructions put together in a smart way. If you have more questions about Lilybot, let me know in the comments. You can download the full sketch on STEAMDivas GitHub, and if you're building your own, follow along with our wiring diagrams and tutorials on steamdivas.org/RobotDiva. Remember, every robot starts with a line of code and a little bit of imagination. I'm RobotDiva, and I'll see you in our next video.